Good day and welcome back to another episode of Down the Rabbit Hole with Building Inspector Steve Nason. Today I want to talk to you about shear walls and walkout basements in ICF construction and how or why they're required. And again, as normal, these are information sessions only. I would highly recommend that you reach out to your ICF distributor or your engineer or record, whoever you're dealing with on your project, because again, these can be a bit confusing, but I will try to demystify a little bit on shear walls and how they work or how you can figure them out on your construction project. Okay. Again, just a recap, ICF construction, you're 2 stories in height, single dwelling, 3 meters from floor to floor height. Now that doesn't count for your floor joists. That's just 3 meters in height, floor to floor. Again, you'll need to know some climatic data for your area, and that'll be snow load, wind pressure, seismic. And now another one that's only found in the ICFMA manual is equivalent spectral response acceleration number, which is a seismic number. They've done a calculation, and you'll find that only in the ICFMA manual. The other thing you're going to need to know is, like most constructions, you'll need to know your bearing pressure, your block, your tie spacing, your block height, and your wall thickness. Okay, so you'll need to know those. Now, when it comes to ICF shear walls, uh, the National Building Code of Canada is out the door. You can't use that one, and I'll explain to you as we go down why you can't use that. Insulated Concrete Forms Manufacturers Association Manual, ICFMA, is one of the manuals, the best manual to use, because that's put out by 6 manufacturers of ICF, and those 6 ones, and they all come with various stamps for your provinces. The other one you can use is a manufacturer's manual, engineering manual, and but there's one item you need to look sure and make sure that that is stamped for the current building code you're using today. Okay, so if you're using the 215 building code, it must be stamped for the 215 or whatever. Now the other way is site specific engineer. You'll get into that with some projects. Now, foundations, again, what you need to know about foundations and especially walkout basements and why those are important. So when you're talking about, you can go with a minimum of 140 millimeter is a minimum thickness of the wall, but above all, the foundational wall need to be, and that's that word, shall be supported at the top and bottom. Okay, that makes it laterally supported, and that uh, takes away from your walkout basements, your knee walls, those type of things that are not laterally supported. And the other thing is that in basement walls, you need to have openings can't be any more than 25% of the wall opening. So if the total width of the openings in the foundation wall is any more than 25% of your wall, that's why you have to move outside of the National Building Code for walkout basements and those things. And if your opening is more than 1.2 meters wide, so those walkout basements will automatically trigger you into an engineering um, design or into the ICFMA manual. I would think that it probably would trigger you into a engineering design. Now, this is where these shear walls are sort of mandated, because again, like if you see here, masonry and insulating concrete forms not in contact with the ground, so that would be above grade. So this one here is for a non-load bearing wall, and this is one for load bearing. But you can see here, no opening shall occur within 1200 millimeters of an exterior corners of a wall, and that's our 4-foot wall. So if you got an opening that's closer than 4 feet, then you're already kicked out of the National Building Code. You've got to go into the ICFMA manual or an engineering, or as we discussed, some other method that other than the building code. And you can see here non-low. Okay, so that's your 4-foot rule. Okay, and if you look at this diagram here, we've got one here. This window door could be, if it's closer to that, then you've got to have a shear wall. Now, shear walls are just basically puzzle pieces that you'll end up doing on your wall. And once we'll go through this sessions, and you've got to look at this. I look at the shear walls as Lego blocks or puzzle pieces. Okay, again, is that, and I'll explain to that as we go down through here. Now, there's that ICFMA manual, and they talk about, and there's your stamps there. Okay, so I'm just going down here. These note sections that I'm showing here are got to be, for any project, a must read. So take them, highlight them, mark them down, and because they are a must read, because they have things sprinkled throughout those note sections that will affect your project. Now, if we go into the note section, and you'll find shear walls in there, okay? And what is shear wall is? It's a solid chunk of concrete, right, between openings, okay, that's required on all four walls, okay? And you can have a 6-inch or smaller opening in those walls for electrical or whatever, you know. So, but basically they're a solid chunk of concrete. And the below grade wall shall have the same number and length as the shear walls immediately above that. So what they're saying is that if I have a 10-foot wall long shear wall between openings on my first floor, my basement needs to have the same thing directly below that. But if I have a 4-foot up at the top and I've got a 10-foot in the bottom, that's okay, as long as they match up. So it's just like a squash block or a load transfer block in a building. You need to have those things flowing right down to the foundation. Okay, and they talk about on item 528, they talk about a vertical bar, concentrated vertical bar, and we'll get into that. There's doweling that you require. Okay, okay, so horizontal reinforcement in shear walls where the spectral response acceleration shall be terminated at the end of the walls with a standard hook. Okay, so they talk about. So again, you need to read these sections, understand it, so that you can do your project accordingly. Okay, so now if I take this table out of the ICFMA manual and I go over here and I find my equivalent spectral response acceleration for that right there, and this is be for St. John area. I can go, okay, bingo, there we go. And then if I'm looking here, that it's if I've got a main floor wall of a 2-story house, or in this case, I got a second floor of a 2-story ICF structure highlighted here. So each one of these will be, you can pick and choose which one you've got here. So if I take that and say, okay, my second floor has a 8-foot high floor to height in there, we're good. So I look at that and say, this is the number of this is a choice or the puzzle pieces that I can choose for my walls. I guess that would be the thing to look at. You know, I've got an 8-foot puzzle piece, or I can have 2 4-foot puzzle pieces, and we'll go over on that. So if we go over to this other slide over here, that's a little more blown up, we get 8 feet. So the best way to look at that saying is that the Lego blocks, right? Okay, if you got an 8-dot Lego block, right, or you've got a 4-dot, 2 4-foot dotted Lego blocks, as you know, with Lego blocks, got dots on the top. So just think of it that way, all right? And again, is it's just like building the Lego walls. The longer your shear wall is, or the longer the Lego piece is that bingo, the quicker it's better for you. Okay, so but that's the way that I kind of got my head wrapped around these shear walls. And ideally with shear walls, you want to start off with the biggest piece. Again, going back to Lego, you want to go back with the biggest piece of Lego you can find to fill that in there. If that doesn't fit, then you're going to have to go with 2 4-foot pieces. And again, is that, and each wall of that 4 walls of that house, they don't have to be identical. They don't have to have, each wall doesn't have to have the same. You can mix and match it as long as those pieces are fitting in there. And we'll show you down here on a diagram. Now, if we go down here and we look at this, and I've got here, the other thing you have to remember here is they have gray shaded bars in here, or boxes in here. Now, those are that, let's say if we've got a shear wall here that has one 8-foot long shear wall, it's going to require a reinforcement bar, 2 bars at the end of those shear walls. But what you can do is you can, with this gray shaded box, you can use the bars that are required for the openings, all right, as your ends, all right. So now the only thing that you have to remember is that if you're cutting a window into an ICF block, and that window is taking 4 bars out of that equation, those 4 bars, 2 would have to go on the right side of the window, and 2 would have to go on the left side of the window. So you may end up with the 2 bars that's required for the window plus 2 bars, vertical bars, that you've removed from the window. Okay, but that's a little more confusing. So, but it's just something to note. The other thing is that, okay, now if we go here, the vertical replacement with a 6-inch tie spacing again, then you go back as per the table, okay, as your table. And I think this one here will show you. Okay, so if we look here, this is our building. Okay, if we go, okay, that's the same thing. If we go up to our, there's our table. All right, so if you look at this, that tells us it's with an 8-inch high wall, it's 10M bar every 30 inches or 750 millimeters. So if we go back up here and you look here, there's your table. It's telling us that vertical, horizontal, that'll tell you right there. So if you're looking at this again, it says it's a building without a walkout, right? So if you've got a walkout basement, then you'll have to find the table with a walkout basement. Okay, so you'll have to find a table that talks about a walkout basement. Right, so these are above grade shear walls with a walkout basement. All right, and then you can pick and choose from there on if you've got a main floor with the 2 supporting. So you there's there's some choices on those tables, and again you have to use the number in here to pick up your seismic information for that area. And that's okay. So we go down to the below grade, and the below grade would be the same thing. So if we got a 6-inch wall, 10M bar at every 18 inch, and that's what we've got here. This is free draining if you got a drain tile out of the bottom. So that would be, there's no back pressures on that wall. Now, when we talk about the bars, so you can see right here, there's 2 bars here. Now, those 2 bars, as you say, you can use the window or opening reinforcement bars if that's shaded gray. If it's not shaded gray and it talks about 3 bars, then this is what you're going to have, but you can't use those 2 bars from the window, because if we go back up here, see how this one's gray, this one's not. Okay, this one shows you that you have 3 bars right there, so you're going to end up with a total of 5 bars plus what the window has taken out. That's the way I believe it works. Okay, so now the other thing that you need to do is you need to have dowels, because again, as I said here, if this is a, let's just say this is a 4-foot wall, a space between 2 windows, okay, and so we need to go over here 4 feet, then you'd have your dowel. So basically what happens is that the shear from this wall goes all the way down to the foundation. All right, so let's just look at this one here. And this comes from the logix, I guess, corner opening Bolton, and logix and Nudura both put out a Bolton on that, but the logix was the one that I found that explained it the best. So you can see where here the shear wall 1 I've gotten. So what they've done here is that there's my issue. I got a 4-foot opening closure. So what we're looking here is for a mixing matching. So shear foot wall. If I go in here and I got a 12-foot wall here, I got a 12-foot wall there, right? But those could be, they don't have to be 12 feet. I may end up going back up into that table and finding out, that I don't have the room in there. So if we go up to that table way back up here, I'll just show you right there. right? I could have had 2 4-foot pieces. So if I go back down to here, watch, okay, we go down here, I could have had two 4-foot pieces in here. So again, is that you're not stuck with that. You can see here that uh, shear wall 4 and 3 are, oh, 3. Okay, so they got a 15-foot there. Again, is that what they're trying to tell you here is that you can take those and as long as you can get the puzzle pieces to fit on that wall right there, you'll be good. So if we go back up here again, just to get you rolling, if you can see here, like in this wall here with the spectral, I could have had one 10-foot puzzle piece, 2 foot 5 puzzle pieces, 3 foot 3 foot 6, or 4 foot 4 pieces of 2 foot 8. Okay, so again, as ideally, I want to put a 10-foot piece of Lego in that shear wall. Okay, I want to use a shear wall, right? But if not, then I've got to go down to my keep going down and see if I can get 2 5-foot ones in there or 3. So it's again as you're looking, think of it as Lego pieces for that. Ideally, you want to go with the biggest piece of Lego and then work your way down. All right, and then you'll get the wall, wall, the shear walls. And if we go back here, those shear walls are all four walls. They need to be continuous down to the basement with dowels. Okay, so like if you look at this one here, it's 12-foot piece. I'm gonna need those walls in the basement, right? That carry it right down to the foundation. So it'll pose some challenges for you folks. I'm not sure how, like when it comes to a walkout, how you're going to deal with this walkout. You may end up with the walkout may not be the full with this whole end wall. It may end up being that you end up with 2 4-foot pieces here, right? Or it may end up with you might have a 12-foot here and there. So again, is that these shear walls are really throw a little bit of a wrench into those things. But again, is that you need to look at that, and that's all driven by if you've got an opening above grade that's closer to 4 feet, or you've got a walkout or something when it leaves the Part 9 requirements, then you're going to end up with shear walls. I hope this helps you out. I'm going to put a link down below for a couple things. One's for the logix manual, and then the other one would be for the Nudura has one that's a color coded one. That gives you a little bit of description. But again, I found that those two are helpful, and the other thing was helpful is just think them as shear walls as Lego blocks and the lengths as the dots on the Lego block. So that makes any sense. So if I'm looking here, I got a 12 dotted Lego block, which is 12 feet, right? Or I got 4 dotted Lego blocks. I need to fit those in the wall to make that wall. So I hope that helps out. Again, I know it was tough for me to get my head wrapped around shear walls, but now I understand what they're there for and how they work. So I hopefully that this sort of wraps this all up and puts a little bit of thought into it. But again, as I say, just adds to the puzzle. Take care and have a great day, and we'll be talking to you later.